Hello, today I'm joined by Dave Heller, who's the chairman of Heller Industries. Welcome, Dave. Nice
Thank you.
to see you. Now, it's great to see you being part of this Panasonic Innovation Center here, Cloud 9. Tell me a little bit about what the oven actually brings to this. A lot of the automation is really corrected or anticipated before the oven.
Right.
What does the oven bring to it?
The oven allows us to report, this whole system allows us to report the condition of the machine, so the operator, so the manager knows that their machine, their oven is operating at exactly the right temperature, the right belt speed, the right profile for this particular board.
Right. So they're able to see that it's not drifting out of spec or anything like that, or running out of nitrogen or these types of problems.
Right. The automation system that we put together with Panasonic allows the system to report many of the process variables, really the temperature of each zone, the belt speed, whether the nitrogen is on, actually the part per million of oxygen if it's a nitrogen machine, whether it's time to do any preventative maintenance on the flux management system. Right. Again, anything that you might want to know about the operation of the machine, we will report. What we can also do is accept information from the host server which says change your profile, or don't accept any boards yet, wait till you're warmed up. Right. So it's a two-way communication.
Yeah, well, one of the big benefits of this factory automation system is that it's going to increase the amount of uptime.
Yes.
So therefore it's going to increase the amount of time that the oven is running, and it's more important that it's not seen to drift out of spec and this type of thing. So that becomes better. What other types of things have you been working on with Panasonic and built into your oven systems?
The machine itself has this automation capability for communicating to the host, but we've also upgraded our edge hold conveyor system, particularly our dual lane. Traditionally, when we had dual lane, we would have two substantial rails, and two sets of a total of 4 rails. But in working with Panasonic, we've re-engineered our 2 center rails so they've got a much tighter pitch, and now it matches the Panasonic output. The advantage is you don't need an intermediate conveyor between our oven and the upstream automation.
And you can take a bigger board size with that?
Yes, definitely an advantage. It was a non-trivial engineering exercise to make a very narrow rail strong enough to span this entire machine at temperature.
Right.
But it works.
Right. But it's 2 different profiles, and you're really just adjusting it by belt speed.
Yes, absolutely. Yeah. You could do that. You could have 2 different profiles for 2 different board types running simultaneously through the machine. A machine like this would have that advantage. We also have another version of this machine which, instead of having 1 big module, has 2 different modules that are independent. So you can actually run different temperatures side by side.
Right.
And this gives you a nice advantage, particularly if you want to avoid downtime, because machines heat up quickly, but they don't cool down quickly.
No.
So you could have a cooler profile next to a hotter one, and so if you needed to switch to that profile, there's no wait time. Right. Just bring it over and run it through.
Okay. What do you think about this issue at the moment in the industry of voiding? Voiding is a huge issue, and there's a lot of oven manufacturers that are bringing out different systems, either vacuum systems or ultrasonic systems, etc.
Right.
What's your position on this?
We have been very deeply involved in that process in a number of different areas. We started working on our vacuum system about 5 years ago, and have been building them for about 2 years now. And at this point in the economic cycle, it's a big part of our business. Right. We're shipping a good number of them each month. They're for traditional SMT, particularly for LEDs. But we also make them for semicon packaging. When people are putting IGBT dies into a package, they need to make sure that the void rate is very low.
Right.
But sometimes it's very high melt point solder.
Right.
That creates a challenge. We have a chamber operating at maybe 500 or 600 degrees C inside our oven with elastomer doors that create the vacuum. It's an engineering challenge, but we've done real well with that. We're also working on a system that uses ultrasonics to eliminate the voids. Okay. And potentially it's a less expensive way to do it. It doesn't give you as low a void rate as vacuum, but very often for most customers, it can be good enough.
Right. I've spoken to some manufacturers that are using a combination of methods to reduce voids. I mean, some people are using different flux chemistries that will reduce voids.
Yes.
And then backing that up with ultrasonic or vacuum and that type of thing.
What we've seen is that flux chemistry can reduce voids, changing the profile can reduce voids, but it's frustratingly inconsistent. Sometimes for no apparent reason, you're back over spec.
Right.
So to use vacuum is like a process sledgehammer. If you're worried about 15 to 25% voids and you can't quite get it consistent with chemistry, you put it through a vacuum and you're less than 1% tomorrow.
Yeah.
And it's very, very effective.
Very effective, yeah. Excellent. Well, I'm pleased to see you're part of this Panasonic initiative. It's very exciting.
Absolutely.
And I want to thank you for joining us today.
My pleasure, thank you.
Thank you.